Okay, this is the review for the unit test on Monday. Mr. Riley buried a time capsule in his backyard. After 10 years, he went to dig up the time capsule, but he could not remember where he buried it. So number 1 says, locate and label the locations where Mr. Riley thinks he buried the time capsule. So letter A is -6.5, 3. So I'm going to start at my origin, which is 0, 0, and I start with my x coordinate first, which is my first coordinate, and I'm going to go -6.5. So -1, 2, 3, 4, 5, 6, and 6.5 is right between -6 and -7. Then I look at my y coordinate, and my y coordinate says 3, so it's +3, so I'm going to go up 1, 2, 3. I plot that point, and I label it point A. So now I'm done with A. Letter B, again, I'm going to start at the origin, and it says -3, 1, 2, 3, and then -4 and 75 hundredths. So 1, 2, 3, 4, and I know that 75 hundredths is going to be closer to 5 than it is to 4. It's actually going to be closer to 5 than it is 4.5. So I'm going to make it about 3/4 of the way, as accurately as you can, and I'm going to label that B. Then I'm going to go on to letter C, and I'm going to label that, I'm going to plot that at 9, 3. So again, I start at the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then up 1, 2, 3. Label that C. Then I'm going to go to D, which is at 1, 2, 3, 4, 5, 6, 7, 8, and then -7.5, 1, 2, 3, 4, 5, 6, 7, and half would be right between -7 and -8. So I'm going to label that point D. Now the second page, you need the first page to finish it, so let's look at number 2 while I have the graph out in front of me. Reflect point B over the y-axis and list the ordered pair of the reflection. Label this point F. So first I'm going to find point B, which is right here, and they're telling me to reflect it over the y-axis. So I'm highlighting the y-axis so I can see where I'm going to make the reflection. So if it's on this side, I'm going to reflect it to this side. Same if it was on this side, I would reflect it to this side. So the first thing I want to do is I want to see how far point B is from my y-axis. So I'm looking here, and I'm going to go 1, 2, 3. It is 3 away from my y-axis. Now while staying at the same point on the y-axis, I'm going to go, I went 3 in this direction, now I'm going to go 3 over here. So 1, 2, 3. And you have to keep in mind that it's going to stay at the same y coordinate. The x coordinate becomes the opposite of itself, and the y coordinate stays the same. So I'm going to plot this point F. Now my new coordinates are going to be, instead of -3, they're just going to be 3, -4, and a half. What is the distance between point A and point C? Now again, I'm going to look and find point A and point C, A and C, and they're on the same, they both have the same coordinate for y. So I'm going to start where it's on a whole number. You can start here, but then you're counting by halves. I think it's easier to count by whole numbers. So I'm going to start at C and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and it's not quite 16, it's going to be 15.5. Now it says, what quadrant is point A in? Well, I know this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So point A is in quadrant 2, or you can write it using Roman numerals. Question 6. The table below shows the arrival of trains as compared to expected arrival times at the train station. So we have a whole train, this actually should say trains, I apologize. Trains and then their arrival times. So the expected arrival time is represented by 0 on the number line. Locate and label each train on the number line A through E. So the first one I'm going to plot is 2 minutes and 40 seconds before the time. So 2 minutes and 40 seconds before the time, that's going to be A. The next one is 3 minutes after. So after 1, 2, 3, I'm going to plot that B. 1 minute, 30 seconds before. 1 minute, 30 seconds is half of a minute. So it's going to be right between -1 and -2. That'll be C. 1 minute, 40 seconds after. 1 minute, 40 seconds is going to be closer to 2 minutes than it is to 1 minute. So make sure it's not exactly in the middle, but closer to 2 minutes. And then 1.5 minutes after. So 0.5 I know is less than, because it's half of a minute, it's going to be less than 40 seconds. It's going to be 30 seconds. So E is going to go right before D. Okay, so now I have A, C, E, D, B on my line. I've graphed them all. Which train was closest to being on time? So we want the train that's closest to 0 on the number line. Well, when I look, I see that 3 is exactly 1.5 minutes away, but so is E. So actually, we have both C and E are 1 minute, 30 seconds from being on time. 2 of the trains were the same distance from the expected arrival time. Are they in the same location? Well, actually, we already found the 2 that are in exactly the same time, which is going to be C and E again. But are they in the same location? Well, if we see E and we see C, are they in the same location? And the answer to that would be no. One is negative, and the other is positive. Which train was furthest away from the expected arrival time? So we want the point that is the furthest from 0. Now, if we look on the negative side, A is not exactly 3 away, but B is. So B would be the furthest away, and it is because it is 3 minutes from being on time. Okay, let's go to the next page. Paula is learning about elevation in math class. She decided to research some facts about Colleentown to better understand the concept. Here are some facts that she found. Mount Brooke is the highest point in New York at 2,353 feet above sea level. Lake Erin is 510 feet below sea level. The elevation of Vito Falls is 487 feet above sea level. The lobby of the Christopher Building is 30 feet above sea level. Colleentown borders the Atlantic coast, which is at sea level. The lowest point of Ike Lake is 375 feet below sea level. So I actually put a hint here to help you with this. I am suggesting that you draw a number line to help you figure out where all of them are. And I'm going to put 0 here at first, and that is going to show you sea level, which is going to be the Atlantic coast. I'm going to label that quick. Okay, so I know I'm done with 0, which is at sea level. So now I'm going to plot the rest of these points. The first one is a positive because it is above sea level. So it is at 2,353. And then Lake Erin is below sea level, so it's going to be about -510. Vito Falls is above sea level, so it's at 487. It's going to be a positive because it's above. Christopher Building is 30 feet above sea level, so that's also going to be a positive because it's above. And then back here, the lowest point is Lake Ike, which is 375 feet below sea level, which is going to be here. Now, none of my numbers on here are exact, but they're telling me which ones I should put on the negative side, which ones I should put on the positive side. Now I'm going to write these numbers from least to greatest, starting with the one I have to the furthest left. So I'm going to write 510. It's actually going to be -510 is less than negative 375 is less than 0, is less than 30, is less than 487, is less than 2,353. Okay, so I'm going to continue to the next page.